Imagine you accidentally touch a hot stove. Your hand feels the heat, your brain says, pull away, and your muscles instantly pull your hand back. A computer works in the exact same way. Even though they are made of metal and plastic, computers have to gather information, think, and move just like we do. To pull this off, they follow a very strict 3-step rule for everything they do. We call this rule the IPO cycle. That stands for input, process, and output. Let's start with input. This is any data or instruction given to the computer. You can think of input as the computer's senses, acting just like your eyes and ears to gather information from the outside world. Next is process. This is where the computer takes all that information, thinks about it, and decides what to do next. This step acts like the computer's brain. Finally, we have output. This is the computer's reaction or final result. It acts like the computer's voice or its muscles, carrying out an action for us to see or feel. Whether you are opening a video game on your tablet or a pilot is flying a jet, every action relies on this continuous, repeating loop of sensing, thinking, and acting. Now, a computer's brain is trapped inside a dark, quiet box. To do its job, it needs us to provide data about the world. We do this using tools called input devices. You use these tools every day. When you slide a mouse across a desk to move an arrow, or when you tap a screen to open an app, you are using an input device to send instructions. Sometimes we want to send these instructions from across the room. Remote input devices, like a TV controller or a smart home app on your phone, let us control equipment from a distance. But computers don't always need us to give them data. They can use automatic input devices called sensors. Sensors act like a machine's own eyes and skin, constantly measuring things like light, heat, or movement all by themselves. For example, when you walk up to a grocery store, a motion sensor above the entrance detects your movement. It instantly sends that information into the computer. This diagram shows how systems stay safe. By using multiple sensors, like 3 temperature checkers instead of just one, the computer can compare the readings. If one sensor gives a crazy number, the computer ignores the broken one and trusts the other 2. Without manual clicks, remote controls, or these automatic sensors, a computer would be unable to gather the data it needs to start thinking. Once the computer has processed all the incoming data, it must show its final decision to us. It does this by using an output device. Some output devices are simple. They display information or play a sound. A basic computer monitor, like the screen you see here, is an output device that displays text and pictures. However, a computer often needs to physically move something in the real world. To do that, it uses a special output device called an actuator. An actuator takes an electrical signal and turns it into physical movement. Take a look at this supermarket checkout lane. Hidden underneath is an electric motor. That motor is an actuator, physically dragging your groceries down the line when the cashier's computer tells it to move. Airplane wings use these too. To fly safely, the pilot's computer commands powerful hydraulic pistons, which are like fluid-powered muscles, to push those heavy metal flaps up and down against the wind. Actuators are the vital muscles of the machine world. They allow a digital computer to reach out and perform physical work in our environment. Even with incredible senses and strong muscles, a computer still needs a way to remember things. To keep its data safe for later use, it uses storage devices. This image shows a hard disk drive. This is magnetic storage. It records data by creating tiny magnetic patterns on those shiny spinning circular plates in the center. This image shows optical storage, like a CD or DVD. Inside the drive, a tiny laser beam is used to read and write information directly onto the spinning disk. Today, we also use solid-state storage, like a USB thumb drive. These have no moving parts. They store data electronically in memory chips, which are essentially grids of microscopic switches. But whether it's a magnet, a laser disc, or a memory chip, what does that data actually look like on the inside? Computers only speak the language of electricity. Because of this, their memory relies on just 2 electrical states, on and off. We track this using binary, where the number 1 means on and the number 0 means off. When millions of these simple ones and zeros are stacked together in long patterns, the computer's brain reads them and turns them back into the video games and documents we use every day. Every photo and every song is saved as billions of these tiny on and off switches, resting securely inside those magnetic, optical, or electronic storage drives. Let's bring all these pieces together by looking at how an automatic door at the mall follows the IPO cycle. Step 1 is input. As you approach, a motion sensor detects you and sends that data into the system. Step 2 is process. The computer's brain receives the signal, thinks about it, and decides the door must open. Step 3 is output. The computer sends a command to the electric motor. That motor acts as an actuator, physically pulling the doors apart so you can walk through. Now it's your turn. Get ready to shout out the answers as we quickly review what we've learned. An input device feeds computer data. An output device shows the result. An actuator is an output that creates movement. Storage drives hold our files using magnets, lasers, or chips, and binary stores it all using ones and zeros. Understanding these building blocks, how a machine senses, thinks, and acts, helps you to see how even the most complex computers around you are following these same simple rules.